Myself Naveen Kumar Saini. In the course of wireless and mobile communication system, today we are going to discuss one of the very prominent topic in the wireless and mobile communication system, that is the long-term evolution. So in short, we call it as the LTE, which is of fourth generation network in the mobile communication system. So this 4G is nothing but, in short, we say this is the 4G. So 4G is a fourth generation, right? So how this generations takes place in the scenario? So first generation was 1G network, or you can say the first generation. So example for the first generation is the AMPS, right? In the second generation, 2G, this is the GSM and CDMA techniques was introduced. Third generation, this is the WCDMA and the TDSC DMA and the evolved DO. Then fourth one is the LTE, and fifth one is the 5G. Fifth generation, we call it as the new radio and technique. So first thing we will go through from where it is started about the LTE network. So this LTE network is standardized by the 3GPP. This is a third generation partnership project, and the standards was given by this forum, that is 3GPP, right? And it was introduced in the release 8 by the 3GPP. So before this release 8, there was a release 7. This was for the 3G network, but the LTE network was proposed or the introduced in the release 8 version. And we say that this is LTE network is not fully 4G network. This is kind of 3.9, right? So this we can say this one is the 3.9G network, because this 4G network is nothing but this is the LTE advanced. So main requirement for the LTE networks are first one is the high spectral efficiency, enhanced peak data rates, and the low latency, flexibility in the frequency and the bandwidth, and last, seamless mobility and inter-networking with the legacy 3GPP and non-3GPP networks. So this is the very efficient features of LTE networks, or we can say the motivation for the LTE network, that spectral efficiency must be very high, and data rate must be very high because of the very big data, and latency must be very low, so that the delay of between the transmission of the signals is very less in the when it is received at the receiver side. Okay, so we will talk about the 4G network in that series, but when we talk about this different overview of LTE network, how it is generated. So as we said, LTE network was released by the 8th version of by the 3GPP. So in that what are different architectural improvement is there. So this was the first release, initial release in the release 8. Then very important feature is the flat IP. So as we are very much aware, before that we in the 3G network we have the circuit switching and the packet switching both in one system, but LTE network is completely IP based, that is the internet protocol. Then transmission techniques which are used, that is the OFDM technique, which are used in the for downlink stream, and for uplink we use the SC-FDMA system. Multiple input, multiple output. This is the antenna array configuration which was introduced into the LTE network. Then duplexing techniques, that is the FDD and TDD, both can be used in the frame structure of the LTE network. Similar to that, then we have the release 9. These are the things which are introduced in the release 10: carrier aggregation, HETnets, EICICI, and advanced MIMO system or the massive MIMO system was introduced into that. Release 11, we have the COMP, coordinate multi-point system was introduced, FEL, FEICIC. Then release 12 and release 13 and then release 14. So release 8 to release 14 are dedicatedly for the LTE system, and although we can say this is a complete 4G architecture was introduced into the from release 8 to release 14. So these kind of releases was there for the 4G system, complete 4G deployment system. After the release 14, we have release 15, which was the 5G network, or the 5th generation technologies was introduced into that one. Okay, so you can say the 4G network was completely evolved from 2008 to 2017. So after 2017, the 5G networks releases was introduced. So what are the different features of the LTE system? So first is that is, as I said, flat IP architecture was there. So all the voice, data, these all are based on the IP base. We call, that is why this structure is called the fully IP based architecture. Then the operating frequency ranges for, in the case of LTE system, is from 700 megahertz to 2.7 gigahertz with the scalable bandwidth. So this is the one of the very important feature in the LTE network, that we have the bandwidth which is of scalable in nature. Just like in the 2G network, we know the bandwidth is 200 kilohertz, GSM bandwidth 200 kilohertz, and in 3G network we had SC-FDMA system where the bandwidth was 5 megahertz. Then in the case of the LTE network or the 4G generation, 4th generation network, we have the scalable bandwidth, means as per the application we use the different frequency band of frequencies. So here the what are different band of frequencies? So this is starting from the 1.4 megahertz, then 3 megahertz, 5 megahertz, 10 megahertz, 15 and the 20 megahertz. So these all are the scalable bandwidth. As per the requirement, this bandwidth can be utilized for transmission of data and the voice as well, right? Then this LTE system also supports the MIMO technology, where the multiple input multiple output transmitting array is there. Suppose we have the example of the 2 cross 2, it means at the transmitter side we have the 2 transmitters and at the receiver side we have the 2 receivers, right? So is similar to that when we have the configuration of 4 cross 4. So in that case this 4 is representing the 4 transmitting antenna at the transmitter side, and these 4 are the receiving antenna at the receiver side. So this configuration is called the 4 cross 4 MIMO system. So in that LTE network also provides the duplexing techniques just like the FDD and the TDD. So the frame structure for LTE, in LTE network, FDD and TDD, these are of different types. So this FDD and TDD duplexing techniques are used for the uplink and downlink of the signals. So as in the previous section we have discussed about the OFDMA system. So this was used in the 4G network. So because this 4G is the very famous term which is used for the LTE network, that is why I am talking about the LTE. Otherwise LTE advanced is the completely fully 4G network, otherwise LTE is the 3.9G. So this OFDMA orthogonal frequency division multiple access techniques is used for the downlink and SC-FDMA single, that is the single carrier frequency division multiple access in the uplink, right? So I hope that each one of you are very much aware about the uplink and downlink. So suppose in this cell we have one base station, right, and in that we have the mobile phone, right? So in this case if this is the transmitting antenna, this is the receiving antenna. So transmitting from the transmitter to the receiver means this section is called the downlink. When your mobile phone is transmitting the data to the base station, so this phenomenon is called the uplink. Okay, so uplink and downlink. So this for downlink section in LTE network we use the OFDMA system, FDMA technique. And when we talk about the uplink, so for that one we use the SC-OFDMA, sorry, OFDMA. Okay. So this why this difference is required? So this difference is required because of this OFDMA suffer the one of the problem, that is a PA PR, right? So this is nothing but the peak to average power ratio, right? So peak to average power ratio, this occurs in the OFDMA system. So because of this reason, in the uplink we use the SC-OFDMA system, but in the downlink, because this base stations have the very high power rating, so we can handle the PAPR issue. But in the uplink, because our mobile phone is very limited battery backup is there, so we it can suffer the very high PAPR ratio. So in that case, we have to change the phenomena of OFDMA. So we use the SC, a single carrier OFDMA system. Okay. Then modulation techniques which can be used in the modulation techniques which can be used for the QPSK and 16 QM or 64 QM. So if you remember in the previous section, in the previous lecture, what we said about the OFDMA system, we convert the wideband frequency to the narrowband frequencies, and these narrowband frequencies are used to modulate the symbols, right? So just like in the in transmitting side, we know there is a first is the data, then we use the serial to parallel converter, and then we map into the frequencies, right? So those mapping onto the frequencies, nothing but is a modulation, right? Modulation of signals with the different frequencies. It means we can use the low data rates bit streams to modulate using the QPSK system, or we can use a 16 QM or a 64 QM. So as the M array is increases, so data rate will be high. Okay, so what influences the data rate, or you can say which is very high, right? So for a high M array scheme, data rate will be very high. Low M array scheme, data rate will be very low, right? Okay. So then we have only PS, packet switching domain is there. There is no circuit switching domain is there in that, as we know all IP based architecture. Then it also supports the self-organizing network, right? Self-organizing network, just like the managed system, it can be also be utilized into that. Home, E-Node B, and the femtocell. So these are the different heterogeneous networks which can be used in the LTE network. So it supports the heterogeneous networks, right? Means it can cover its own domain, and it can be compatible with the previously generated generations, just like the 2G, 3G, and so on. Or so this 2G, 3G is the 3GPP forum architectures. Another we have the another non 3GPP architecture, just like the Wi-Fi, right? Wi-Fi, Bluetooth. So these all can be manageable in the LTE system. So this is very flexible in that. Okay, so highest theoretical data rate for that one is 300 Mbps in the case of LTE network, and this is for the downlink case, and for the uplink case 75 Mbps data rate, theoretical data rate is there for the uplink, right? So these all are the features for the LTE release 8. So if we talk about the LTE architecture overview, into that this LTE architecture comprises basically two parts. First one is the radio access network, and second one is the core network. So radio access network, it is also called the EUTRAIN, right? Evolved Ultra Network. So if you remember, in the third generation network, we use the only UTRAIN, right? UTRAIN. So this was in the case of 3G network, right? So when we add this evolved, so this terminology is converted into the 4G system, right? Okay. So second is the core network, that is also called the evolved packet core, because a data network can be managed by this network, that is the EPC. So if we see in this architecture of LTE, first one is the user equipment, just like the mobile phone, tablets, or the laptops. So these are the user equipments. Then we have the EUTRAIN, that is the evolved UMTS, terrestrial radio access network, right? So this interface between the user equipment and with the EUTRAIN is the LTE UTRAN. So you can say LTE UU. This is the interface between the all the radio devices with the this base stations or the EUTRANs. Then EUTRAN is connected with the EPC, Evolved Packet Core. The interface for that one is the S1. EPC is connected with the PDN, that is the Packet Data Network, that is it is connected with the interface SGI, right, Serving Gateway interface. So this whole architecture we can see in that scenario, that first one is your user equipment which has the connected with the EUTRAN. So EUTRAN comprises nothing but this is the E node Bs, right. In the 3G network we use the node B only. So in 3G we use the node B plus RNCs, right, but in the 4G or the 4th generation we use E node B, and this E node B comprises everything like the RNCs and all these things. Okay, so the interface between the LTE and the E node Bs are the UU interface. If we connect it like this, so this is also nothing but the UU interface. So in UTRAN, these E node Bs are connected with the X2 interface. So X2 interface is there between all the E node Bs. So this is the example where the two E node Bs are mentioned. If suppose we have the another E node B, right? If we have the another E node B, so in that case the interfacing between these two will be again X2 interface. So next section of this EU in this LTE architecture is the EPC, Evolved Packet Core. So Evolved Packet Core comprises this component just like the MMEs. These are different MMEs, mobile management equipments. HSS is there, PCRF is there, and the P gateway, right. So home location register is there. The HLL, just like in the GSM we use the HLR. So here we use the HSS in the case of the LTE system. Then PCRF and the packet gateway is there in that. So in this we see that this E node Bs are connected with the interface SIU interface. This is the S1 interface, S1 with the user plane interface between the serving gateway, right. So two types of gateways are there. First one is the serving gateway and second one is the packet gateway. So this serving gateway is within the architecture in which the signals are S1 and which is for the user plane, and this E node B is connected with the MMEs. So these are mobility management equipment. So in that the interface is S1 interface, but it is used for the control plane, right. So use nothing but for the user plane, and this C, that is nothing but the control plane. Okay, so we can say this complete architecture is divided into two parts, user plane and the control plane. So S1 interface between the E node B and the serving gateway is the user plane interface, and the E node B with the MME, that is the mobility management equipment, that is the interface or the controlling interface. So, okay, so all the controlling efforts which occur into the LTE system, it can be takes place by the S1C, right. So okay, so next interface is the S10 interface. This is between the MME and different MMEs. S11 interface between the MME and the serving gateway. Then we have S6A interface between the MME with the this is a home serving location system, register, in which this interface takes place. Then S5 or S8 interface, this is between the serving gateway and the packet gateway. Then GX interface between the PCRF and the packet gateway, and the outward world can be connected or accessed by the this PCRF, that is RX interface, and the SGI interface between the P gateway and the internet and the other outside world networks are there. So these networks can be connected with the internal LTE architecture with the different interfaces like the RX and the SGI. So here it is representing if EUTRAN entity. I will discuss one or two only. That EUTRAN consists of the E node Bs interconnected by the X2 interface. Okay, and it is connected to the EPC with the S1 interface, and X2 and SI are logical interfaces, right. So there are basically two types of interfaces are there. First one is the physical interface or the logical interfaces are there. When we talk about the physical interface, so this in the physical interface take care by the different modulation techniques, right, just like the QPS, KQ, 16QM or 64QM as we discussed in the previous slides. So in the physical, so all the modulation techniques, signal processing which occur into the physical interfaces. So when we talk about logical interfaces, these logical interfaces takes place all the authentication, controlling efforts, or the management, authentication. Okay, so all these things covered by the logical interfaces, right. So this physical interfaces is nothing but this is used for the user data, and signaling part is taken care by the controlling interfaces into the LTE system. So e-neutron must be clear to all of you. All the controlling part can also be taken care by the inode Bs, and these all inode Bs are connected with the each other. So each inode B have the information about another inode B which is into the e-neutron system, right. So this phenomena is very much efficient in the LTE system, which can be taken care by the different nodes. So one of the equipment I will discuss here only, that is the eNode B, that is called the eNode B. So what is the functionality of the eNode B? I will discuss about that. The eNode B basically evolved node B, which supports the both the duplexing techniques, that is like the FDD and the TDD. So it can be work in the FDD mode or the TDD mode or the dual mode operation into the in the LTE system. And the eNode B also perform some radio interface related functions. So what are those functions which can be take care? That is the radio resource management, transfer of user data across the UU and the S1 interface, radio channel ciphering, deciphering, and the integrating protection of the user data. It supports the IP header compression, load balancing, synchronization, and mobility control functions like the handover can be takes place by the eNode B. If you remember in the GSM, the BSCs, MSCs was there who take care about the handover situations, but in the eNode B is the only responsible entity which take care about the handovers. Dual connectivity is there, inter-cell interference coordination is there. Then it is responsible for the processing and maintaining end-to-end connection setup and releases of the system. Then transferring of NAS messages within the access spectrum, selection of MME from the MME pool pooling, then paging process, positioning, MBMS, and the broadcasting of the warning notification to the UE. So these all are the features which can be performed by the eNode Bs only. Next is the X2 interface, which interconnect between the different eNode Bs, and the functions of the X2 interfaces are: first one is the intra LTE access system, the mobility support, which allows the eNode Bs to hand over to the control of a particular UE to another eNode Bs. Transferring of context from the source eNode B target to eNode B to maintain the e-neutron services for a certain UE. Okay. Handover cancellation, which informs the target eNode B that handover will not take place, and UE context releases. Load management, error indication, inter-cell interference coordination, etc. So these all are the as I said, two component I will discuss right now about the LTE. So if you go through it, the another components of functionalities are there for the LTE system, just like the MME is there, and different interfaces are there to which you can go through your own. Okay, thank you very much.